Dah record tak? Masih pusing-pusing kan? Okay, start Assalamualaikum and good evening to our lecturer and fellow friend. Today we're gonna present about Panama wilt caused by Fusarium oxysporum, and we have 4 members here. My name is Muhammad Asnadazi, and Ahmad Aspa, Muhammad Irfan, and Jason John. And the first, I'm gonna pass to Wan Irfan.
Okay, thank you, Aslan. So, Panama disease, the scientific name is Fusarium oxysporum FSP cubensis. The kingdom is fungi. Phylum is Scomicota, class Sordariomaceae, order Hypocreates, family Nitriaceae, genus Fusarium, species F. oxysporum, and subspecies FOFSP cubensis. So that is the taxonomy for Fusarium oxysporum. Fusarium wilt is the most destructive fungal disease affecting banana plantation across the globe. It is caused by a type of soil-borne fungi called Fusarium oxysporum FSP cubensis. The disease probably originated in Southeast Asia. The first observation of the disease was made in 1874 at Eagle Farm near Brisbane, Australia. It was then reported from Panama in 1890. So that we call Panama disease. Within a decade, the disease had spread to Costa Rica and subsequent outbreaks occurred in Suriname 1906, Cuba 1908, Trinidad 1909, Jamaica 1911, Honduras 1916, and Guatemala 1919. The disease has since been reported from most banana producing countries. The pathogen penetrates through banana roots and dominates the vascular tissues, which disrupts the dissemination of necessary nutrients from roots to the upper parts of the plants. Several management strategies have been executed in controlling the spread of Fusarium wilt. However, they did not manage to provide long-term solutions to the problem. Current cutting-edge technologies, particularly through omics studies, may provide better alternatives to solve these long-running issues. Here we discuss the current knowledge on Fusarium wilt with special emphasis on diagnostic tests available and on current disease management approaches and rising new omics technologies that can be adopted. So next is Asfa.
Okay, next is life cycle of Fusarium oxysporum FSP cubensis. Okay, this Fusarium have two reproduction process, which is mitotic sporulation, which is asexual, and meiotic sporulation, which is uh, which is uh, meiotic sporulation across potassium. Okay, next, generalized life cycle of Fusarium SPP following plasmogamy and karyogamy. Across and self-peritaceum respectively produce recombinant and clonal meiotic spores. These form haploid mycelium HM, which in turn form three types of mitotic spores, while conidia, micro or macroconidia, can colonize the host. Chlamydospores, in addition to direct colonization of the crop, can overwinter and develop into peritaceum to restart the cycle when conditions are favorable. Okay, next. Okay, next is life cycle of Fusarium oxysporum disease in banana. Okay, they have several stages, which is firstly spores, uh, micro and macro conidia and chlamydospores rest in the soil or on alternative hosts such as weeds. Okay, next, chlamydospores germinates, which is stimulated by root exudates and the germ tubes penetrate banana roots. Okay, third, uh, FOC, which is Fusarium oxysporum cubensis, grows through the cortex to the epidermis and mycelium invades the vascular system. Okay, then conidia and chlamydospore are constantly produced in the vascular tissues. Conidia are rapidly distributed through the plant via transpiration system. Mycelium and gum blocks the vascular tissues and first symptoms of yellowing are observed in the older leaves. Uh, Fusarium colonize and destroy more vascular tissues, provoking intense wilting. Uh, Fusarium infected plant dies, and the follower plant, which is the son or the daughter of the plant, which was contaminated by the mother plant, also will uh, will get this disease. Okay, next.
Okay, I'm gonna continue with
Sorry for
Panama
disturbance.
symptom. Okay, for the first, about internal. Uh, this Fusarium wheel or Panama wheel is a typical vascular wheel disease. The fungus invade the vascular tissue through the root, causing discoloration and wilting, eventually killing the plant. The progress of the internal symptom can influence the first appearance of the external symptom. The fruit do not exhibit any symptom. The characteristic internal symptom of Fusarium wilt is vascular discoloration, which varies from pale yellow in the early stage to dark red or almost black in the later stage. Internal symptoms first develop in the feeder root, which are the initial infection site. The fungus spread to the rhizome and then the pseudostem. Okay, the second one about externally. The first sign of disease are usually wilting and yellowing of the older leaf around the margin. The, the yellow leaf may remain erect or collapse at the petiole. Sometimes the leaf remain green except for spot on the petiole but still snap. The collapse the collapsed leaf hang down the pseudostem like a skirt. Eventually, all the leaves fall down and dry up. Splitting the base of the pseudostem is another common symptom. Other symptoms include irregular pale margin on new leaf and the wrinkling and distortion of the leaf blade. The fruit does not show any specific disease symptom, and that's for Panama. Okay, I'm gonna pass to Jason John.
Okay, next. Okay, next is diagnostic test for Fusarium, which is Fusarium blood test and PCR test. Okay, this test is which is to test the presence of Fusarium oxysporum on your seed. These are two tests, which is the Canadian Grain Commission blood test, which is 5-day test. It will give a percentage of Fusarium oxysporum found in each sample to 0.5%. It's an excellent follow-up for the Fusarium DNA test. The next, the PCR test, which is need 2-day test. It will detect the presence of the DNA of Fusarium oxysporum in the sample, but does not provide a quantitative result. Okay, next. Negative result from either of these tests mean that you can get your grain clean at any seed cleaning plant in Alberta. Sell your grain for seed in Alberta. Okay, next. Positive result mean that your grain cannot be sold for seed in Alberta, and then the grain could be used for seed or sold out of the province, which is below. Okay, next. Don't test. Vomitoxin. A don't test is used when you want to check your grain for the presence of DON or vomitoxin. It is 1-day test. It uses an ELISA, which is enzyme link immunosorbent assay. It is a method to detect the DON-mycotoxin. Provides you with the amount of the mycotoxin present in the sample, expressed in parts per million, which is ppm. Okay, when it is negative result, it is an indication that if Fusarium oxysporum or Fusarium culmorum are present in your grain, they will not produce mycotoxin at the time of the test, which is both species can produce DON, vomitoxin. Next, for the positive result, it do not identify which species of Fusarium is causing DON production, or if the fungus is still viable, because DON is a chemical produced by a fungus. It will not disappear even if the fungus is no longer living. Okay, next. Okay, next, Jason.
Thank you, Oscar. So the next is about drainage. So this is the explanation about management on this disease. So first, the fungus cannot be controlled using fungicide and cannot be eradicated from soil using fumigants. Drainage, environmental condition, and soil type influence host-pathogen interaction. The chemical, biological, and physical factors responsible for this phenomenon are not well understood. Next. So the method that we apply on this disease is resistant method. First one is by sanitation by immediate removal of diseased plants surrounding soil from the field. Use of healthy rhizome for planting. During cultivation, avoid root injury. Use crop rotation with rice or any other cereal crops. Arbuscular mycorrhizal fungi have been shown to reduce disease severity in short-term greenhouse. Next, the addition of highly antagonistic organism to soil around banana. Roots give protection to plants against the wilt. Lastly, tissue culture plants are free of bacterial, fungal, and nematodes pathogen and should be used to establish new planting and whenever possible. Uh, since the resistant method in tissue culture is the most effective method, so the effect shows that breeding programs have successfully created genotypes that show resistance to Fusarium wilt in banana, as reported by Nowak and Kursky 2000 2. Possibility of microbial inoculation in tissue culture plants free from pathogenic infection involving the use of beneficial microbes in vitro co-culture and on hardening stage. Lastly, in vitro co-culture of tissue culture plants with microbial consortia show engaged growth character like few dosteme heights and great in nursery stage. This is some of our reference. So that is all from our group on on Panama wilt disease. Thank you.